Okay, so can someone give me a non-commutative, I'm going to call this one hash or pound. Can someone give me a non-commutative binary operation on A or B? Okay, so let's check it out. A times B equals A, or A hash B equals A. If you flip it, you get B hash A equals B, and these aren't the same. If you flipped it, you get a different answer. So it's non-commutative. Good job. Anybody else have one? Because it's perfectly valid, but there might be other examples. Are there other things people thought of that were non-commutative as binary operations? A, B, A. I don't know why, but it's called smiley face. You're good. So A, B is equal to A, but B, A is equal to B. Now, as a fun little problem that you might try, there are 16 possible binary operations. Because you you have two choices here, two choices here, two choices here, and two choices here. So you multiply all those together. So you get 2 to the 4th binary operations. So you've seen one that is commutative and 2 that are not. And a fun little problem you might try is to see how many of those binary operations are commutative and how many are not. You could either try to brute force it, you could try to reason through it, or you could write a computer program to brute force it. And all three would be really good fun exercises. Yes. Yeah, it turns out. So the diagonal doesn't matter because if you swap A and B, if you swap A and A, it doesn't matter. If you swap B and B, it doesn't matter. So as long as you write rows and columns in the same order. So then the question is whether this is equal to this. Well reasoned, well conjectured. Okay. Now we would either need to write a proof, or we would need to do a computer program. If you have a finite number of things, it's acceptable to do a computer program that brute forces over. I like your idea here about looking for that symmetry along the diagonal.